Okay, let's have a look at naming this alcohol molecule. Now we know it's an alcohol molecule because it has an OH or an HO attached to the carbon chain. We can see that the longest continuous chain of carbons is 3. Therefore, this is going to be a propane. But instead of being propane, we replace the ane at the end with an anol, and this becomes propanol. Sorry. But what we want to do is say where the OH comes off or the HO comes off. So we're going to call this propan 1-ol because it comes off the first carbon. Right, let's see if we can name this molecule here. If we look at this molecule, we see it's got single bonds, carbons and hydrogens, but we can identify a functional group, a hydroxy functional group or an OH functional group, and this corresponds to an alcohol group. Okay, so it's going to have the end of its name is going to be anol, and we are going to put between the an and the ol the number where the OH comes off. And in this case, the size of the molecule is 4 carbons because that's the length of the longest chain. If we number to where the OH is from the side so it has the smallest possible number, it's coming off the second carbon. So this molecule is going to be called butan 2-ol. Okay, so let's have a look at this molecule. We can see that there are 4 carbons in the longest chain. So it's going to be bute is going to be the part of the name here. We're going to see that it has 2 substituents, 2 groups or atoms coming off that aren't hydrogen. We have an OH coming off the second carbon and a CH3 coming off the third carbon. Now, the OH group has priority to the CH3, so we always number it so the OH gets the smallest number it possibly can. So when we go to name this, this is has a methyl group coming off the third carbon, so it's going to be 3-methyl, and it has an OH group or an alcohol group coming off the second carbon, so it's going to be 3-methyl butan 2-ol. Okay, so let's have a look at this molecule here. We can see that this molecule has a double bond, and the longest chain with the double bond has 4 carbons. So this is going to be a butene, but the double bond comes off the second carbon, so this is going to be but-2ene. What we also notice is there is a functional group, an OH or hydroxy functional group. It comes off the second carbon as well, so this is going to have the end 2-ol. So this molecule we could call but-2ene 2-ol, where the ol replaces the e at the end and goes after the en bit. It's a wee bit messy, so in another one of these shorts, I'll explain how to name it another way. Okay, so this molecule, I'm going to give you an alternative way of naming this. So usually when I explain about naming alcohols, we use the suffix anol, but we have the option also of using a prefix when we already have a suffix present. So in this case, this molecule has a double bond coming off the second carbon of the longest chain of 4 carbons. So it is a but-2ene. So because we're using the suffix ene, we're going to put the OH group as a prefix. Now, the name for the prefix for an OH group is hydroxy. So we can use the hydroxy prefix instead of the anol suffix. So in this case, we can call the name 2-hydroxy but-2ene. Okay, so we have quite a long alcohol here. It has methyl groups coming off and an OH group coming off, so the OH makes it an alcohol. We're going to the longest chain, identify what the longest chain is, how long it is. There are 6, so it's going to be a hexanol. We can see that there are 2 methyl groups. Now, since the OH group has priority to the methyl groups, we will start numbering from the left-hand side. So the methyl groups come off the second and the 5th carbon. So this is 2,5-dimethyl butanol. But we also need to say where the OH comes off. So we are going to say the OH comes off the second carbon. So the actual final name for this is 2,5-dimethyl hexane 2-ol. Okay, so this molecule has OH groups coming off a main chain. So it is an alcohol. We can see that the main chain contains 1, 2, 3, 4, 5 carbons. So it is a pentanol. What we do notice, however, is that there are 2 OH groups. Now, we know when we have 2 methyl groups, we put the prefix di in front of methyl. So we're going to do the same with the alcohol here. So we're going to put diol to say there are 2 alcohols, but we also need to say the position the carbon is that the OH comes off. So this molecule is going to be called pentan 2,2-diol. Okay, so here we have an alcohol molecule because there is an OH group attached to the carbon chain. We can see that the longest carbon chain is 4 carbons, so it's going to be butanol. And the OH groups comes off the second carbon. And remember, the OH has a numbering priority to the CH3 group. So we go 2 for the OH group, so it's butan 2-ol. And the methyl group must come off the third carbon. So this molecule will be called 3-methyl butan 2-ol. Okay, so here we can see that we have an OH functional group and a Cl functional group attached to a chain of 4 carbons. Now, the issue that we have here is we can number the chain 2 ways. We can number it from left to right or right to left. If we number it from left to right, OH gets the smallest possible number. If we number it from right to left, Cl, or the chlorine, gets the smallest possible number. It so happens that OH groups have priority to haloalkane groups, or halogen groups, sorry. So we're going to name it from left to right. We're going to have the OH coming off the second carbon and the chlorine coming off the fourth carbon. Therefore, the name for this molecule is 4-chlorobutan 2-ol. Okay, so this molecule has been drawn with the carbon chain being vertical, but that doesn't matter to us. This is actually a common molecule. It's called glycerol. It's found in lipstick and is found in icings. We're going to name it systematically. So it has 3 carbons in its longest chain. It has 3 OH groups coming off it. So it's going to be propan 1, 2, 3 triol, with the tri meaning that there are 3 of the ol or the OH groups, and the numbers all representing the place on the main chain that the OH comes off.